Hi, question number 12. At 1200 hours, a ship has position vector 54i plus 16j relative to a lighthouse, where i is a unit vector due east and j is a unit vector due north. The ship is traveling with a speed of 20 kilometers in the direction 3i plus 4j. Show that the position vector of the ship at 1500 hours is 90i plus 64j kilometers. Okay, so here's the situation. The ship is here. Let's say that this is 54 and we've got 16 somewhere here. So that's the position vector of the ship right here at the harbor. And now the ship is traveling in the direction of 3i plus 4j. So a unit vector in that direction, because you told it in the direction, that means it's a unit vector. So the unit vector is going to be the vector itself divided by its magnitude. And that's going to give you 3i plus 4j over then 5. So if you want to find the velocity is going to be equal to all of that times its speed, because we're told the speed is 20 kilometers per hour. That's the magnitude. So there we go. That's going to be 4 times 3 is 12i plus 16j. So this is the velocity of the ship. Now in that, so what we're going to try to use the velocity to find the distance travel. The distance after 3 hours, because the time taken is 3 hours. How do we know? It started at 1200 hours and we want to know at 1500 hours. So 1500 take away 1200 is 3 hours. So the distance would then be the velocity multiplied by the time, and the velocity is what it is here, 12i plus 16j multiplied by the time is 3 hours, and that gives us 36i plus 48j. The new position of the ship is going to be its original position, the position vector that was given, 54i plus 16j. So 54i plus 16j plus the distance traveled, that's the distance in kilometers. So we're going to take 36i plus 48j. If you were to add these, you should be able to get 90i plus 16 plus 48 is 64j. And that's been shown. So that it is equal to this, and here we are. Now, find the position vector of the ship t hours after 1200 hours. T hours later. So that means the velocity multiplied by time is equal to the distance traveled. So the new position, okay, the position vector, new position vector after t hours is going to be the original vector, 54 and then 16, okay, add with the speed of the ship, and the speed was found to be, the velocity was found to be 12 and 16, so we're going to take t as the time plus 12 and 16. So we've got then 54 plus 12t and then 16 plus 16t. So that's the new position vector of the ship, or you can write it as a unit vector. So that's going to be 54 plus 12t vector I plus 16 plus 16t vector j, and here we are, that's the new position of the ship. For the third part, a speedboat leaves the lighthouse at 1400 hours and travels in a straight line to intercept the ship. Given that the speedboat intercepts the ship at 1600 hours, find the speed of the boat. Okay, for the third part, we need to know at 1600 hours what was the distance traveled by the ship. So the ship had traveled a distance of 54 and 16, add to the velocity multiplied by the time, 12 and 16, and that should come 54, 16 plus 48, 64, and that's 102 and 80. Now that's the distance traveled by the ship. The boat needs to do this in 2 hours. So in 2 hours the boat would have traveled half that distance. I mean, in 2 hours it would travel 51 and 40 to intercept the ship. So therefore the speed of this thing, so what would be the speed? So the speed of the boat is going to be its magnitude, which comes to 64.8 kilometers per hour. Right. Now for the third part, for the fourth part, I was messing around and with some vectors here, but it doesn't really matter for the time being. We need to find the velocity of the speedboat relative to the ship. So what does that mean? Velocity of the speedboat relative to the ship. We're going to take the boat minus the ship. So what I want to establish here, this is what I was doing, the boat minus the ship. So what's the velocity of the boat? It is 51 and 40. In fact, I meant that this was velocity. Minus, I said distance there, but it's not good, so it should be velocity. Minus the speed of the ship, which is then 12 and 16 as we found there. So if we take away that, we're going to get 39 and then 24. So that's 39i plus 24j. The last part is not very difficult. We need to find the angle, the direction of the speedboat makes with north. So north is here, and then what is the speed or velocity of the boat? It is 51 and 40. Let's say 51 is here and 40 is somewhere there. So we've got this one 40. So that's the boat. The angle it makes with the north here. So this is the north. So we can call it angle theta. So we're going to take this is the opposite. That's the boat. Let me just call this the opposite, and this is the adjacent, 90 degrees. So I'm going to say or alpha is equal to tan inverse of the opposite over the adjacent. Opposite is 51 over the adjacent, which is 40. If you do that with a calculator, you get an angle of 51.9 degrees with north. Here we are. Take care.